what we're going to do today, I didn't bring the agenda up there. I was going to, but so what we're going to talk about here is for like the first hour or so, we're going to go through some soil classification taxonomy, and then we're going to have a short break. The next part that we're going to transition to is we're going to have sort of a recap of what we've talked about, and you can ask some questions either in chat or on mute, want clarifications on stuff that we've talked about over the last several days for this class. And then we're going to have a sort of it's combination. I call it a practice CST exam. And most of the questions would be ones that you could encounter or similar to those that you would encounter on the CST exam. And there's also some questions that pertain to what we learned that wouldn't necessarily be on the CST exam, but it's geared more towards the soils end of it, not so much code. That's what we plan on doing today for our time. So with that, I just wanted to mention little a brief history of taxonomy. It's not going to get into a whole lot of details, but soils, describing soils and having soil science came out of Russia. So, Katie, if you want to pipe up here, I know she did study Russian in college, and she says that, would you say 2 or 3 times a year your Russian comes in use in relation to soil science?
Yeah, this year one more time because we're
One
doing
more
this
time.
virtual
We're
training.
really, yeah, we're really going hog wild with using your background. So no, and anyway, just it's sort of interesting to know where it comes from. Is that in Russia, this is where soil science first got its start. Most of the old terminology, we had some terminology like Chernozems and Bernozems related to different things, and now we use different terminology. But the original ones and some of the old soil science books you'll see will still use that reference. But late 1800s, soil science came out of Russia. In 1894, National Soil Survey, as part of the USDA Weather Bureau, started in the United States. And then we had a person in 1938 came out. Marbut had soil classification system, and the reason that's important is just so that you understand why in the United States, and if anybody wants to unmute and pop in here or put it in your chat, do you know why in the 1930s soil science became such a high priority in the United States? Anyone have a guess? I'll give you a few seconds if somebody wants to type in.
Yeah, in the chat we had Dust Bowl.
Exactly, Dust Bowl. Is we had severe soil erosion, dust bowls, droughts. We had severe problems maintaining crops and cropland in the 1930s. That's exactly what it was. And so there was, some thought elsewhere, again, 1800s in Russia, but it really hit home here in the 1930s with the Depression and Dust Bowl days in America, as trying to keep up with, make sure that we have conservation tillage and contour strips and things like that really came to the forefront in the 30s. And that's why soils really came to a forefront of, we need to manage that as a resource, not just do as we wish, so to speak, out there as with farming. And then in 1950, there was a soil taxonomy, more use of airplanes and things like that. Started getting an idea of putting air photos as a base layer. Some of the old surveys that I remember seeing from like even in the 1930s and 40s. I remember one, Richland County was one of them. All they had was a colored background. There was no air photo, and it was really hard to tell where you were because it just wasn't helpful without having that air photo as a base layer. And then in 1990, the Web Soil Survey first came online of starting to put things that starting to transition away from paper copies to paper books, paper soil surveys, to putting things on the internet, on the web, and having a digitized set of soil maps. So, oh yeah, here's one, Barron County, same thing. It's got the colorized backdrop. Sort of neat, but it's really hard to see where you're at if you don't have the air photos as a background. But published soil surveys like this one, Barron County, 1948, has, profile descriptions, tells you what kind of soils you have and some characteristics about them, some basics descriptions. Again, they were out there doing the field work and gathering that and putting together surveys so that people can make decisions for land use, things like that down the road. So, pedology is the study of soils in their natural environment. The word comes from Greek pedon or soil, and logos, the studies are like, geology and all the other ologies out there. But pedology is the study of soils in a natural environment, and what we're looking at is describing, what we do for our profiles and our soil testing and for citing them is describing sort of that three-dimensional block of soil and trying to write a description for it. So as far as the soil classification and end of it comes is the same thing as they're looking at sort of like this cube or this block of representation of soil and trying to classify it or study it. So, pedology is based on pedogenesis, soil formation. Morphology is the soil characteristics, what it looks like. And then the classification is categories based on those shared characteristics. So, the difference in, we do sort of the pedology end of it. We look at pedology, morphology. What does the soil look like? How do we classify it? And then there's another group of soils on here, edaphology, that's dealing with basically sort of how soils influence and reaction to it. But we're basically more into classification and what the soil is. And then we apply that with our loading rates and our code to how we can use it. So let's look at soil morphology a bit here. We have some things called diagnostic horizons. So we mentioned them a little bit over the last couple days worth of training. And a diagnostic horizon is the specific horizon in the soil profile, in that three-dimensional column of soil that we have, that's used to differentiate between soils, suborders, orders, grade groups, subgroups. And we'll talk more about what those are. But it's a specific soil characteristic that helps group them together. So just like we'll be talking about like orders, suborders, great groups, classifications, it's just like, all mammals. We know what characteristics of mammal are. They're warm-blooded, they have hair, they have live birth, they provide, milk from their mothers, those kind of things. So we know that that is a diagnostic. Those are diagnostics of a mammal, or we know the difference between animals and plants. Plants have a cell wall, animals don't. So those are some basic characteristics. So the diagnostic horizons are like that also, is that certain horizons, they group certain soils together based on their diagnostic horizons. So we'll have two different kinds. We have the surface horizon, or what they call epipedon, and then a subsurface horizon. Those would be the two different diagnostics we could have. So common surface horizons in Wisconsin, pretty easy. And again, don't worry too much about knowing all this terminology. I know we're throwing a lot at you because what we're trying to get to is we want you to be familiar with what some of these terms are. So when you look up in the soil survey, there's a lot of soil science in the soil survey, and we want you to be familiar when you see certain things to hopefully it'll trigger your mind to go, okay, I've seen that and this is what it means. And we know that if I see this, I'm going to have similar soils. And that's what we want you to get out of that. It's not so much learn all the terms and be quizzed on all these different terms that are out there, because there's a lot of them and a lot more that we're not even sharing. But a histic would be an organic horizon, so that's usually like a swampy, mucky, things like that. We don't see, anything that we're dealing with for septic systems. We're probably not going to be on a site that has histic. So that's like peat moss, plant fibers, those kind of things. Molic and ocrics are sort of the middle ones, and those are basically, a very high organic matter. Molics or mollisols have molic horizons. They're going to be like your deeper prairie soils. And then umbric and oak has less organic matter, and it's sort of a oak is a pale. It's sort of a more of a generic, and same with umbric. We just there are different horizons that do key in. Again, histic's going to be organic, high organic matter swamp. Molic's going to be your prairie soils. The others you don't have to worry about splitting out which one's which. Just oak going to be less organic matter than an umbric. So this is what some of them look like. You can see the oak creek in the upper left. There's topsoil there, but it's sort of lighter in color. It's not very dark. The Moloch one on the upper right has more organic matter, more of your prairie soil. You can see it's fairly deep. A lot of good organic material there. And then the bottom one in the middle, that's the histic. That's sort of like a wetland kind, and very black, a lot of organic matter. Sort of get you an idea what the different diagnostic horizons look like. And here's another one that sort of looks a difference. You can see the difference in organic matter that the Moloch one, prairie soil, has a lot more organic matter in it than than the one on the left. So you can also see this sometimes on some of these air photos. You can see some things, and some of this is due to erosion also, but that does affect the soil types over time. But you can see more of the depositional areas here. We more have more like epipedons because it's more, deeper profiles, where the ones up on the ridge tops have less organic matter and they may be ochric, and you can sometimes see that just from air photos. So, what are some diagnostic subhorizons that we have in the state? Well, these are some ones that pertain to us a little bit more than the surface ones. Is we have one that's called an Albig horizon, and that's an eluvial. Remember, E is exiting, so it's leaving. So it's a mineral horizon from which clay and iron aluminum oxide have been removed. So it's a horizon where you have a loss of iron and aluminum oxide and clay. You could have both of those are removed from that Albig horizon. A cambic horizon is just sort of it's like a catch-all. It's There's some development, but it not argillic or spodich, and those are going to be the next we look at. So a cambic is just sort of a catch-all horizon that there's some color or structure change, but nothing else has happened. An argillic horizon is one that's important for us. That's an eluvial or illuvial. That's an in. The I is an in. So that's an accumulation layer of clays. So if you're starting to think, if we got a horizon that's leaching stuff out or losing clay, you can start to see there's probably a relationship. If we have an Albig horizon, we may very well have an argillic horizon below it that's accumulating those clays. So if one's losing, somebody's got to be gaining that. And then we also have a spodich horizon that's an illuvial with an I. So that's a mineral horizon with accumulation of iron, aluminum oxides, or soluble organic chelates. Well, what do we see here? If we have an Albig losing and we have a spodich, these are gaining ones down here. We may have an Albig above if we have a spodich or argillic below. Not always, but we'll see those relationships. So here's an example of one with an Albig horizon. You got this lighter colored horizon here, usually right below the topsoil, where we have a loss, an eluvial with an E and exiting, and we have an argillic, which is accumulation of clay down below. So when you're texturing this, this may be like a silt loam. This might be a silty clay loam, for instance. It might be the same texture, but this one will be a lighter textured silt loam, and this would be a heavier textured silt loam. This has a clay accumulation to it. So here's one with a spodich horizon. I should have copied Albig here, but right here, you see this gray ashy horizon? That is also an Albig horizon in eluvial or exiting. So we have a little thin topsoil here. We have an Albig eluvial, and we have a spodich illuvial with an I in input. So we have iron oxides that are accumulating, iron aluminum oxides are accumulating in there. And then this one is a cambic. Remember I said this is the catch-all horizon. So we have topsoil, and then what's going on below? Well, it's not spodich, it's not clay accumulation, but there's some structure, there's some color change, but really not enough to make a spodich or an argillic horizon. So those are some of the diagnostic ones that we see in the state. Now, as far as the naming convention goes, or how we identify the horizons, if you are 100% positive on being comfortable using these, you can. We have a lot of people in their soil tests that do not list the horizons, on a soil test with the letters to classification. So if you just want to do 1, 2, 3, 4 for horizons or something like that, you're more than welcome to. Because if you put down letters and say this is an A or an E or a B horizon, or we'll talk about some other letters that you can put down, that means something to a soil scientist. I've had people that have put down, first horizon's A, second horizon's B, third horizon's C, fourth horizon's D, fifth horizon's E, sixth horizons F, G. Well, there's no such thing. And so then, it's very disconcerting when things are not in the sequence that they should. So an O would be used to denote an organic horizon. Now for us, if we're putting any kind of septic system and you have an O horizon, most likely it's not going to be suitable. The only exception to that would be is sometimes you'll see in some literature, especially forestry people, forestry soils people will use O to denote leaf litter or something on the ground surface. So if you see that, don't be too concerned, but that's the wacky forest soil people, and I don't count them as real soil people. But anyway, A horizon is usually the topsoil horizon. And then we have the B is sort of the subsurface horizon, and a C is basically a parent material. It's just the natural parent material that has not been affected by. If you remember, we talked about cambic having some kind of color or structure development. Well, a C substratum is basically not affected by any kind of development. And so the A and the B is typically what we refer to as the solum, or what's the development. I know yesterday we had a question about, do we report structure below 42 inches? Well, reason we don't always do that is because that's usually below the solum, and that's a classification kind of thing. Is we really don't have development in undeveloped parent material. But again, if you see structure in an undeveloped parent material because that's the way it naturally was laid down, we should still report that. And then the ones that slip in here out of order, so A, B, C, E will fit in here. And why do we call it an E horizon? Because it's eluvial, starts with an E, so we call it an E horizon. So that would be a loss, or that leaching horizon out of here. And then the B, because it has development in that solum, it has development of accumulation of clay or humus or structure or color development. That would be your B horizon, which is basically your substratum or your parent material that's had some kind of pedogenic process, a soil development process take place to it. So again, we have A horizon, topsoil. B has some kind of development in your pedogenic process. So roots, color, clay accumulation, something that's happening. This is our sort of growing zone. And then you can see here our substratum that's beneath our processing, our pedogenic processes to soil, beneath our growing zone. And you can see here the roots stop, they don't go down any farther. So this is our undeveloped parent material, our substratum. There's no development processes or soil development processes that are taking place. So here is a profile. Now I'm going to have you look at that, and then we're going to go into one of our QR code Slidos. And based on what you know here, how would you, or what would you call the development or the horizonation of this profile? So we've got a profile here, and all the letters that we threw at you. How would you call that? So, what is the master horizon sequence for this profile? All right. Well, you can continue to answer if you like, but the correct answer is A, E, and B. So the A topsoil up here, this is all topsoil. It's all fairly uniform here, just that this is smeared on the sidewall and this is sort of broken on the top here. You can see the corn stubble along the top. But this is our A horizon. So it's not an O because it doesn't appear to be organic derived. It's a mineral horizon, not organic. I suppose if you want to call the plant material corn up here an O, you're really stretching it. We don't call plant material, for the true soil scientists, we usually don't call leaf litter, stubble, or anything like that an O horizon. But it would just be the A horizon for the topsoil. Then we'd have an E, this eluvial or exiting material. We're leaching out of here. And then we have the B down here, accumulation. This is actually a clay accumulation down in here. So this would be the profile sequence here, AEB. Well, once we have our letters there, are what we call the master horizons, and those are always capital letters, then we could have a subhorizon identifier. So we may have a second letter, which would be lowercase, that may give us, you know, different information or better information or additional information rather. So we could have something. So for instance, if we did have an O horizon, one we would have would be sapric, well decomposed, very mucky, or you could have hemic, which is moderately decomposed, or fibric, non-decomposed. It's a lot of plant materials, like a lot of sphagnum moss, things like that. But again, we don't deal with the O's. But then you can have other ones. So for instance, if you had like a buried A horizon, we talked about fill the other day. So you'd have an A and then some kind of developmental B in fill, and then another A that's buried. If you did that, it would be an A, capital A, little b, for a buried A horizon. We might have the G in here, if we have a glade horizon, we looked at those, black over grays, you might have a G. And that would, if you have like a BG horizon, would be a B horizon that has development. And what did it develop? It's a glade, those kind of things. So A here, A with a P, you'll see that a lot of times that's a plowed horizon. Just for instance, like in this one here, you can see how it's pretty level, pretty straight. This is, corn farm field. This is a developed or a plowed farm field. So that would be an AP horizon. The other ones that we would commonly see is in northern forest soils, and we'll talk about this, and S for accumulation of sesquioxides, which is iron aluminum. It's a red color. And then we also see a T, and we'll talk about that, which would be accumulation of clay. So that would be our illuvial with an I and inputted horizon. But those would be the typical ones that we will see in Wisconsin. We may see a G, but that would be bad for us. But if we see a G, see a P, I shouldn't use C because that's in here, but we would use G, P, S, and T. Those are going to be the most common ones that we will have identified in Wisconsin soils. So some diagnostic subhorizons that we would have again are Albic horizon with the E, which is eluvial irons. Our cambic horizon with development. Oh, we could have had a W. I forgot to mention that on here. A W is again sort of a catch-all. It's just a structure or color development, but not enough to be a sesquioxide in S or T, a clay accumulation above. So cambic might be just a BW or just a plain B. In argillic horizon, where we have illuvial with an I, accumulation of clays would be a BT. And then a spodec horizon would be a BS, the sesquioxides, a BH, which would be humus or organic matter, or BHS, which would be both. So our diagnostic horizon is not only is it Albic, but it's an E, cambic, BWs, argillic, BT, spodec, BS, BH, BHS is what we'll see. So here's another profile. And I think this is one we saw before, but looking at it, what do we see here? What are some of the features that we see? We have a thin A horizon in here, or mineral horizon with organic matter that's dark. We have this light ashy E horizon where we're eluviating or exiting material out of. And then it's sort of hard to see here, but that's a BS. And we have this reddish brick red iron accumulation in here, stuff that leached out of here. This probably all was uniform when this was first put down, uniform iron, and this leached out. So as you can see, it's important for us to know and why we're talking or spending time on learning the morphology and the classification of soils is that if you saw this soil and you didn't understand that this is a natural soil forming process, that this area leaches out and accumulates here in a BS horizon, and you skipped day 4 learning about soils, and you learned all about redox yesterday, you would say, oh, this is a red mass, this is maybe redox. It is not due to wetness, it's due to a natural soil forming process in this particular type of soil, especially sandy northern forest soils, that they have an A, they have usually a well developed and identifiable E horizon, and a developed and identifiable accumulation of irons. But that is not a redox. Now, there may be other redox in, and this is where it gets tricky to trying to see redox on top of a BS horizon. It can be difficult, but that's what's going on here. So here we have sort of the umbric, or sort of the, it's not malic, it's not, heavy organic. We have an albic or an E horizon in here, and we have our argillic horizon. Same picture we saw before, but now we're adding the BT. It's not just a B horizon argillic, it's a BT. It actually has an increase of clay enough, and there's definitions of what requires that. And again, you don't have to worry about that. You just have to realize if you see a BT, you're going to have an increase of clay, a significant increase of clay. So don't be surprised again if you call this silt loam and this is silty clay loam or something, because it has an increase of clay. And then again, the cambic horizon might be just a BW. It's got some color development or structure, but there's nothing else to it. So again, the ones that we looked at in Oak might be an AP because it's plowed, an E horizon, and then a BT, we got accumulation of clay. A Moloch Epipedon, an AP because it's plowed, and then a BW because there's not much development down here. And then we could have like a histic epipedon with an OA, and then it's sort of hard to see in here. Should have done that in yellow. An E horizon, this ashy color, and then a BS. And again, if you don't know that this is an ashy color, maybe you might say, hey, that's glade. We talked about glade horizons. That's not what's going on. This is an E alluvial. The iron and sesquioxides are moved out of here, and you're seeing the natural, basically quartz sand grains, the natural color of the mineral content behind it. So it's not covered up. There's no oxidation on it from the iron. So we mentioned the hydric soils. We saw some of those yesterday. We talked about redox. So here we can see a reduced stone. Here we can see some models around it. Here we can see sort of reduced topsoil kind of color, and you got these streaks in here along the root pores, pretty ugly. Hydric soils that we usually have, wetland, bad stuff would be an O or possibly an A, and this stuff it's glade down below, so that's an A and a BG, a B horizon that's glade. It's gray. And we saw this one here, talking about, wetland plants. You can see the plants are up on a knoll here. You got the lower area, the trees that are buttressing here to try and keep themselves wider at the bottom so they don't tip over. And what do we have here? We got an A horizon up above, and then it's not an AP because they're not plowing in here. This isn't a plowed farm field, so it's not an AP. It's just an A horizon. And then below we have a BTG. Well, now we get tricky. We added a couple of them in there. So what's that mean? It's a B horizon that has a clay accumulation and it has glaying going on. So in here, you don't really see an E horizon, but it still could, accumulate in here out of the A or up above. It's just not enough to form an E horizon, but we still have an accumulation. So it's an A and a BTG. It's clay accumulation and glade at the same time. So there are a few oddities that can happen in here. We could have what's called a second parent material. So the glaciers did wonderful things. They may have put a loess cap on top of till, or outwash on top of till, or till on top of outwash, or something like that, or loess on top of residuum in various areas. So a second parent material, you have your main letter AB, and then you would have a 2 in front of it to denote a different parent material type. So if you see that in any kind of soil survey that breaks that out, that's what's going on, is that's denoting you have a second parent material. If you have an in-between horizon, that's sort of it's sort of not really a B, but it's maybe we had a weak E horizon, but not enough to truly call it an E. It's sort of a half and half. You would do this slash. So you say like an EB horizon is basically it's a weak E, but somewhat a B, but more E than B. And if it's the other way, BE, it's more B. The first one is the predominant one. So you could have a horizon that's sort of an in between kind of thing. It's not really an either or, it's not a strong candidate for an E kind of thing. And a slightly different horizon. So you could have a BT1, a BT2. So that's a B horizon with clay accumulation, and you could have a level 1, a level 2. Well, why that is different? It could be a structure change. BT1 could be subangular blocky, BT2 could be prismatic or columnar or something. Or you have BT1, which is still clay accumulation, but it's silt loam. BT2 is now silty clay loam. It got even stronger yet. So it could be a color structure change, rooting change, something that makes them different, but they're still similar enough. They're both BT horizons, but to separate which BT, you'd have a letter, or sorry, a number after the subletter. And then a slick and slides, a BSS. That's sort of an odd one that it doesn't happen too often in Wisconsin, but I think I got a picture of that coming up here to show you what that looks like. So the like this one here, two parent materials, the fancy, if you want the $10 term to throw around to make yourself sound smart, it's called the lithologic discontinuity. So it's a break here that you have one parent material down here. This is glacial till. So it's stones, rounded, they're scattered in here, jumbled up mess. So that's a till because it's not sorted. And so here's the 2C. So this is the parent material as it was laid down. You can see there's no structure really in here. And then here you have a BT. You can see how this is, you can see it looks heavier. There's some structure. There's some clay accumulation in here. So this is part of the till. But then up here, what happens? There are no stones up in here. So that's your cue for this is a different parent material. That why are there no stones up here and down here? This is till material. This is the lust cap. This is the windblown silt cap on top, but we're far enough down in the profile. This is also a BT, a clay accumulation, but then we have two BT because this is a second parent material with a clay accumulation, and then a 2C second parent material and undeveloped parent material. So you can have, in here, this is, I mean, you don't worry about this, but this is clay films. On here, you can see the addition of clay and the lust cap, and then, bridging in here. That's just from a different slide, a different show, but gives you the idea of the second parent materials and how they would be stacked up. This is what slick and slides look like. This is basically the PEDs of the clay particles slide against each other. This is typically more down south where you have the high shrink swell clays. And what happens is they slide against each other and they sort of polish up the faces. In some of the heavier red clays in the state, I have seen this a little bit, where they actually polish up against each other and slide, and they get real shiny surfaces. And that's from the shrink swells, them rubbing against each other. Very rare in the state, but there are a few spots that I have seen it. So here's a slide that shows us three parent materials. So we have the AP, a plowed A horizon on top. And usually, how you know it's plowed is one, you're standing in a field. And two, if you're not sure if it was a field or not, it usually has a nice, abrupt, smooth boundary. It's very clear because that plow comes down a certain amount. And even if it came down here at one time, this stuff would have been incorporated up into it. So the A horizon may not have been that deep. It may incorporate things in. That's why we don't see E horizons a lot on plowed fields, is because usually that E was right below the A and the plow came down and grabbed the E and pulled it up into the A horizon and mixed it in, and we sort of lost it over time. But AP and E horizon, so eluvial or exiting material, we have a BT where now it's accumulating. And then you can see here, this is sort of more like uniform kind of looking stuff. And then, whoa, we get this stuff down here with rocks and stones and other things in here scattered. That's our two. So our second parent material still has some clay accumulation. So it's a BT, second BT. So it's a 2 BT2. But then down here, all of a sudden, we got material that we lost our stones and now it's nice, clean sand. Maybe this is a third parent material. So maybe this is, lust cap, till, outwash or something. So we have three parent materials. You could have that. You could potentially have more. I haven't seen more in the state, but most I've seen is three. But anyway, that sort of gets us an idea about what some of those letters mean, when we see them in the soil surveys or they're in the description. So you got somewhat of an idea what to expect out on the site. So soil classification. The US uses classification of soil taxonomy, and it contains different categories. So order is the most general grouping, and then we go suborder, great group, subgroup, family, series. So this is just like if you remember your biology classes, we got different kingdoms. So your plant or animal kingdom, or then we break into, okay, your animal kingdom. Well, what kind are you? And then we keep branching down that you're a vertebrate, or you're a mammal, or what kind of mammal, you're a primate, what kind of primate, you're a humanoid, and then you're human, and sapiens and homo sapiens, and that's how we keep narrowing down to what we are to differentiate us from a whale or a horse or something else. And so the same thing in soils is that the order is the most general grouping of similar soils. Then we have suborders that sort of take out, as you can see here, moisture, temperature, chemical, textural features. Great groups differentiating horizons. Subgroups, we have a typical type, an intergrade, and not one of the other two, and then a family. So then we're starting to really narrow down that we're very similar ones, and then we get down to the series name, which will finally define what that soil classification is. So here's a way to look at it, sort of like on a pyramid kind of scheme, is that order. There are 12, currently 12. They're proposing a 13th right now for basically urbanized soils or soils affected by man, because now we're getting so many of them. They're thinking about coming out with a 13th one. But there are 12 recognized orders right now. And of that, there are 63 suborders, 250 great groups, 1,400 subgroups, 8,000 families, and I'm probably out of date on this, but the last I looked, how many ever years ago, there were over 19,000 soil series. So a lot of different things. So these are the ones that we see in Wisconsin. Is the most common one we have is, I should have backed up, alpha sols. Then the next group that we have would be mollisols, spotosols. I have ultisols on it, but really there's only one of those in the whole state. It's sort of different. And then those would be the ones that we would encounter. And then entosols and septosols, and then hardly any histosols, because again, we're not going to be installing on organic soils. But those would be the orders that we would see in the state of Wisconsin. Gelisols are permafrost soils. Andisols are like volcanic soils. Iridosols are like desert soils. Vertisols are like high shrink swell, like Texas soils with the big cracks in them. And oxasols are highly oxidized, usually subtropical or tropical soils. Like the oxasols are highly oxidized red soils, like those you'd see like in the outback of Australia or something like that. So I sort of gave it away already, and I forgot that I had this in here. And as I said it, I sort of realized. But so I'll let you guys figure out what's the most common soil and order in Wisconsin. I already said it if you're paying attention. I know I shouldn't have given it away because I forgot I had this question in there. So if you want to log in, okay, I hope everybody gets this one right because I said it. Oh, somebody's just being nice. Make me feel good that I tripped some of you up. But yeah, the most common soil order in Wisconsin is alpha sol. It's by far the most common one. And then the other ones we would see it probably spotosols up in the northern part of the state, depending where you are. That may be the most common one near you. And then a little bit of the others scattered around, antisol and septisol. Mollisols are the prairie soils. We don't have a lot of that, but down in the central part, south central part of the state, there's a few down there. Especially if you get near like the Janesville area, there's pretty big pockets of mollisols. And altisols, there's only one in the state, and that's over. Where was that again, Katie? Over sort of like by the Barron area, something like that.
Chautauqua somewhere, I
Chautauqua,
think. I want to
Chautauqua, that's
go.
where it was. Yeah, we want to go. We want to go see it. I mean, we're going to nerd out on looking at an altisol, but yeah, it's over by Chautauqua. So anyway, these are the soil orders in Wisconsin, sort of showing you a left or right, the difference between weathering that they have. So an entisol is little or no development. It's a recently inceptisol. You can think of just like an antiseptic kind of thing. It's very sterile. There's not a whole lot going on. Then we have, as we go farther and farther to the right, there's more and more development until we get to the oxasols, which we don't see again here. Those are highly oxidized, highly weathered. A lot of the nutrients have been leached out of them, so to say. So that's also the difference that you can see here with alpha sol and altisol. Why we don't see much, we only see one altisol in the state, is an altisol is basically a highly leached out alpha sol. It's basically a poor alpha sol is that's been so leached out that it doesn't have very good nutrients left anymore. And spotosols are that way because coniferous forests sandy, they're highly leached out. There's just not a whole lot of nutrients there because they've been highly developed. So we don't have to know is all the details of what all the words mean here. If we say something like, "Oh, that's a fine loamy mixed active mesic oxyaquic haplodolph," you're going to go, "What?" You don't need to know. All you have to know is that when they put the words together, this stuff in here talks a little bit about what the soil is, and they may have like a fine loamy or fine silty, gives you an idea of what the soil texture is. Usually they'll have a texture like a loamy or silty or sandy loam or something. And then the first word here is the subgroup. Then the great group is the first part of the last word. The order is the next one, or suborder is the next one, and then the order is the end. So the important thing is that it's this is the bigger end, and this gets more specific as we go this way. And so if you see an elf on the end, that is an alphasol. An OLL on the end is a mollisol. An OD is a spodosol. So those are the important things to see: alphasol, mollisol, spodosol. That'll tell you what kind of soil. And now based on that, we should be able to figure out if we have an alphasol or mollisol. Remember, we're going to have a molic epipedon, dark organic matter, deep. Alphasol, we're probably going to have a medium organic surface horizon, or organic content surface horizon, and some kind of development below, most commonly like BT horizons. Spodosols, commonly a thin A horizon, usually an E horizon, usually a BS horizon down below. That's a typical spodosol. The other thing to pull out of this is if you ever see the word aquic, aquic means wet. And if you see that, this is going to be a wet soil. And the farther it goes this way, so if you have an aquic haplodolph, if you have an aquudolph, that's wetter. If you have a hap aquolph, that's wetter yet. So the farther aquic gets this way, the wetter it is. Just something else to, that would be useful for us. Biggest thing is knowing what order it is by the last letters here. And if you see the word aquic in it, the farther it is to the right, the worse it's going to be for you. So again, last syllable, ALF is alphasol, OD is spodosol, OLL mollisol, and if you run into histosols, IST, those are going to be swampy things. Hopefully, we don't have any of those, but those are going to be the most common ones that we're going to run into. And if you would have other ones like an ENT would be an entasol. You may run into something like that on occasion, some other odd ones. And again, aquic for the term is to the right, whether it's going to be for you. So the soil series name, we mentioned that, is named for a town or landmark where the soil survey series was first identified. So for instance, if somebody says Antigo Silt Loam, even though you don't know the classification for it, it's going to tell you what the soil series. So it usually has a texture as part of the name. So a silt loam, it's an Antigo Silt Loam. And it's not restricted to one state or one county. So, for instance, Hagerstown, Maryland, that's where it was identified, but it's been found all the way from Tennessee and Kentucky. And if you're mapped as an Anago silt loam, all those mapped areas are going to share the exact same characteristics. So we talked about all the other features that fall in. So horizonation, they're going to be very similar. Wetness, topography, climate, remember all of our soil forming factors, they're all going to be the same because you're not going to find Antigo silt loam in China. You're not going to find Antigo silt loam in Australia. You're probably not going to find Antigo silt loam in Texas because of different moisture, different parent materials, that's different. So here is actually the map of Antigo silt loam soil. This is the border here between Wisconsin and Minnesota. So you can see Antigo silt loam is found over towards Mille Lacs. It's found in Minnesota. St. Paul area has a lot of Antigo silt loam soil. So Antigo silt loam, and it's classified as a haploid glossodolph. So ALF, it's an alpha sol. But you can see these red blocks here. This is where it is. So predominantly, over here in Antigo, this is where it was first identified, or the example of it was from. But Antigo silt loam is scattered across northern Wisconsin and into Minnesota. So the next question I have for you: did you know there's an Antigo silt loam song? So I want to hear your response to that. See what anybody knows. I knew somebody. I knew somebody was going to say that. So again, are you kidding? You know the words. So you got
I
a
think
whole,
we had a volunteer in the chat to
yeah, I'm about to
sing
say.
that.
So somebody's saying that they got choreographed routine as they sing it. Somebody else says they know the words. So we got volunteers. We'll find out who you are. We will hunt you down and we'll make you sing it. No, I'm just kidding. But yeah, there is an Antigo Silt Loam soil song. The professor from Madison, Francis Hole, instrumental in getting the Antigo Silt Loam as our state soil. So not only is there a song, it's our state soil. And then he penned a tune and put words to it. And then we had, I don't know if this will play over, but Carl Wacker, he was actually a previous state soil scientist. And if you really want to hear it, go on this. I found this on YouTube. Go on YouTube and type in Anago Silt Loam song, Carl Wacker, and you'll be able to hear it. It's a pretty catchy tune. It's, Antigo, the soil, There you go. So anyway, sorry that the audio didn't come across. I didn't think it would, but yeah, pretty catchy tune. So anyway, Antigo silt loam soil. It is our state soil, And just like we have the state bird is the robin. Anyway, we got a silt loam soil just like our state bird and state fish and everything else. So anyway, want to talk a little bit about mapping units. Some of the older soil surveys, they will have a mapping unit in here. The first two would be the soil series name, like KD might stand for Kidder, and D would be a D slope, and then the letter behind it is an erosional class. They moved away from that. The online ones now, they will still tell you that information, but you have to look up the the mapping unit. So now the reason they moved away from this is that you can see if they say KD, if it's only two letters and you have 19,000 soil series across the US, you start running out, is KD, is that Kidder? Is that, Kildare? Is that, there's so many different, only so many different letter combinations you can make to make 19,000. So what they started doing is just having a number combination here. So this is soil mapping unit 4410. You click on it, and that is Kidder or Anago silt loam or whatever, and it will tell you the slope classes and give you information about it. So where to get data, books, if you can still find them, they're around. They do update them and correlate them, especially with the online surveys. The nice thing is that Barron County, when it was next to another county, sometimes the mapping symbols didn't match up because the one guy mapped it differently in one county than another. So now being online, they're seamless across county boundaries, across state boundaries, especially things like that. And they've correlated a lot of that. Also, it's most up to date for, like I said, any errors or issues they've had to fix. So paper is still good if you can find them. Sometimes they're portable to take out in the field, but the online ones are pretty handy. So you can go on the internet onto the Web Soil Survey. It's USDA NRCS website. Gets data all across the US. So it's great for pulling up information on there. There are various soil web apps that you can download. And so this one here, Soil Web, is the one app, and you can get it through Apple Store or Google Play. And once you have it and you have location enabled, you just click what soils do I have, and immediately wherever you're at, those soils come up. So I've downloaded that on my phone, and then you can get into more details about figuring out what the soils are in your area. But very handy because I'm here at, I just say get soil data, and I'm on Matamidi. Typic Utasaments. So there's one with an ENT in it. So that's an entasol. So it says A and E, a BW1, BW2, C1, and C2 outwash planes. So that's what it comes up with. So anyway, that's some of that. And Katie, did you want to jump in and sort of show them how that works?
Yeah, I was gonna share my phone screen and then I'll show them. So I think you'll have to stop sharing. Yeah, there we go.
Yep.
Okay, so you guys should be able to see my screen then. This is on my personal iPhone. So I wanted to show you guys a couple of apps that I find useful when I'm in the field. Web Soil Survey is great when you're in your office, but when you're in the field, it's extraordinarily clunky to use. So because of that, some smarties in California at UC Berkeley created an app called Soil Web, and that's just what Matt was talking about. So I'm going to show you kind of how it works. So this is generally it opens up to a splash screen, but because I've had it open today, this is what it looks like. So if you just click Get Soil Data right up at the top of the screen, it'll open up what is mapped for your area. So Matt had said that his area was an entasol. My area is mapped as an alphasol, but we can open it up. So if you click each of the soil descriptions there, it'll open up the series description, which is extremely helpful in understanding kind of what's going on there. So where I'm located at right now, it's mapped as an Amnicon series, and I know that's truthful because I live here. So we can kind of read the series description. So that taxonomic class, like Matt was saying, is a very fine mixed active frigid oxyaquic. So you can see oxy and aquic is in the name, not great, not great. Verdic glossodelph. So go through all the names and figure out what it means. Verdic being there, we're about as close to a vertisol in Wisconsin as you can possibly get. Oh, so I do see in the chat that someone said that Google Play says that Soil Web is not available for newer Android phones. And that's going to be an issue with a lot of things for Android, is that people don't continue to develop the apps for them because Android is a difficult development atmosphere. So people don't often don't continue their app. So if you have an iPhone, I guess it's available. But we can look kind of at the typical PDON here. So we have an A horizon, an E horizon, an EB, a BE, so those mixed, a BT, so accumulation of clays, and then a BTK, which Matt didn't talk about, but K meaning an accumulation of carbonates in it. So you'll see little globs of pinky brownie ready stuff in it. So you can see that. But if we go back to, we click go back, we can also click here location and click open Gmap at this location. And this is something that some people maybe don't know about this app, because everyone knows that you can find where you're standing currently. But if you open Gmap, it'll open the map unit so you can see where I'm located, I guess. Hello, welcome to Katie's house. But if we scroll somewhere else in Wisconsin, so let's just say we go down to, gosh, where is this? Somewhere in Burnett County, probably. Maybe it's still Douglas. Let's go down a little further. Okay, so we're in Washburn County now, and zoom in. Let's say we want to do a soil test. We know we're going to go do a soil test somewhere on Silver Lake. And we drop a point there, we can see the map units that are there. So Keweenaw, Sainer, Vilas, Pence. Knowing these soil series, this is going to be a pretty good soil test. So that's one app that's really useful for soil testing. A second one that I wanted to show is called Rocked. And I don't know if this is available for Google phones, Android phones either, but it definitely is for iPhone. And it's an app that's created by UW-Madison, and it has all of the underlying mapped geology, so the bedrock. So you can open it up, zoom into where you want to go. Let's say we're back in that, well, we're not in Washburn County, but we'll go here. Click, drop a pin there. It'll open it up. It tells you it's the Chenguatonga Volcanic Group. It's a gray basalt flow, so you kind of know what the underlying bedrock is
It
in
is
here.
available on
Oh,
Android.
it is.
Yep.
And then third one, this one, full disclosure, my husband made, but and it's a paid for app, but there is a free web version, and I encourage you to use the free web version. But you can see all of the vegetation of Minnesota. Wisconsin doesn't have an app like this, but our vegetation is relatively the same. You can find the plant that you're looking at, and this comes in useful when you're trying to find out whether or not something's a wetland. You go down and look at, on that slide Matt had about wetland vegetation, you can see what its wetland indicator status is. So right down there. So those are just 3 apps that I wanted to show you guys that I find useful when I'm in the field. And
Yep.
stop.
So some very handy stuff. Some tools. Like I said, we're not going to make you experts at soil classification or identifying stuff, but we want you to understand that if somebody says, "Hey, we're going out to a site and that's mapped Anago," and I know there's people around here and they even use terminology more than I do, and I can't keep up with all the counties I work in, and oh, that's Mark Casco. Okay, so what's that mean? You gotta tell me. I'm not that familiar with the 19,000 soil series names, but like that, it's Map Vilas, it's Map Saner, but you work in an area and you'll start to know that, okay, that's marked and or mapped Anago. I know what I'm gonna see when I go up there. That's marked or mapped Plainfield or whatever the soil series happens to be, or knowing that, hey, it's mapped this. Ooh, that's a wet soil. I'm gonna have issues up there. I'm gonna have all I can do to get a mound, or it's going to be a holding tank, or based on the soil types, you're going to be able to know some information and have sort of a leg up on how to interpret those and what those mean. So that's mostly what we're trying to get understand what the classifications are like. That the K, we didn't talk about that because it's not too common, but yeah, we got some carbonates and stuff out there, and
Yeah. And
that's what that's
rarely will
showing.
you see someone dig that deep in the clays to hit the carbonates,
Yeah,
because you're going
we'll
to get
also get
redox
some of
at
that
6 inches.
Fox Valley area. We will get some of them with carbonates in the red clays over there. They'll get white carbonate that'll show up over there. So that does happen, but it's just not too common. But again, you know what, in your area, if you see that, you'll know what to expect. So with that, we're running a little behind here, but does anybody have any questions? I didn't think this would be too popular. Anybody have any questions or want us to cover anything of what you've learned over the last 3+ days, or want us to clarify something for you? Don't jump all in at once.
Well, I'll jump in if people
Oh,
aren't going
sure,
to enter
Katie.
anything in the chat. Can you
troublemaker.
open your slides back up to where you had labeled like the Spodek horizon and the
Um,
to that slide? Because we had a question a couple of days ago about how do you tell the difference between a redoxamorphic feature and other color patterns in the soil? And so I think one of those had, like a Spodek and Albic and redox features in it. I don't recall exactly, but
yeah, there was one that might have down on the bottom.
yeah, to be able to
Um,
like kind of explain, it's so hard to do in
let's see.
pictures, but
Yeah,
differentiating between those features, those pedogenic features versus redoxamorphic features.
yeah. So this one here, I think this is actually just the root here that's a shadow. But you look down in this corner here, there may be some, it's hard to tell. But again, it's here we have the topsoil, here we have the E horizon. Right below the E is where we're going to have that iron accumulation in here. Now below this, if we start seeing, something that starts appearing down lower, you can see how this is darker here. This is a really good BS horizon. And then down here, it starts to fade out. We don't see much. So if we start seeing things popping up in here, a red spot, but you also notice that this is almost uniform all the way across the horizon. It's not like a blotch here, a blotch there, a blotch here. It's sort of, you can see it starts out darker and it gets lighter as it goes down. That's pretty typical of the BS horizon. And the same thing with the E. E is going to be nice and uniform gray across, right below the topsoil, but then have something below it that doesn't have redox in it. That's going to tell you whether it's an E or if you're glade, because we had some of those others. Where was it? Like this. This is glade, and then gets into some other things down below that are glade. But that's sort of the difference. Trying to look at that in here, it looks like there may be some spots that are starting to show up in the bottom here. It's really hard to tell again from a picture. I don't have a good example of a BS with redox in it. Again, here's our spodec up here with the E and then the BS underneath it if you start seeing spots below. So yeah, I don't have a good example, but I should maybe look for one to get a better example there. But yeah, anyway, that's would be the differences. Again, it's important to know whether you have an eluvial horizon or if you have, a diagnostic horizon there or whether you have spots. And again, the spots aren't probably going to be uniform all the way across the horizon or masses. It's probably going to be sort of blotchy, as we talked about, more models than having a whole horizon of it.
Thank you. And if people
All
really
right.
want to learn a lot more about the diagnostic horizons, they can watch the previous versions of Pout's Chat because we've been talking about them a lot. Okay, so we have a question in the chat. Can we go over lamellic bands, if it's okay, if it's bad? When do you need to stop the soil test? So I don't think we have
Well,
any pictures of
lamellae
lamellic
are
band.
yeah, lamellae are a soil forming process, and they are like little thin bands that appear in the soil. It's sort of what you could think of as they're almost like a mini BT horizon is what they are. And so, that's what's going on is that they're little, I guess, almost like precursors to a BT horizon is what they are, and they're like clay rich. They're typically found in sandy soils. They'll often have a color differentiation because they're associated also with iron oxides. So it's sort of a precursor to like a BS or a BT horizon. So they're not on their own, a limiting factor or necessarily causing us problems. And a lot of times, if you have those, I've seen some of those like in Plainfield sands, and what they'll say is, from whatever, you don't have to describe each one, but you can say, hey, from 40 inches to 80 inches, I have this, whatever, I have 10YR, 6.4 sand and interspersed with about every 4 to 6 inches, quarter-inch lamellae that are 10YR 44 loamy sand or sandy loam or something. So you can sort of group them. You don't have to go through and describe every little lamellae as you go through. It gets a little difficult. I got some images online, but they're not the best at showing what we have around here. This one is actually pretty decent. I will share this one here. So this is a pretty good example, sort of like this. It's sort of sandy up above, and then you get down a little bit, then you'll start seeing these kind of things, these little lamellae, and these are basically little layers of of clay that are working their way down. So these aren't the problem, but you have to be careful that in here you might have little spots in between of redox that start showing up. So lamellae themselves aren't the problem. They should be described, but you have to look carefully in between here to make sure we don't have redox showing up, or these aren't getting like weakly cemented or something that we're starting to have redox show up right above the lamellae, that they're being impervious to downward movement of water and we're getting redox or something in association with them. That would be the only concern. But lamellae themselves aren't a problem. It's if they're causing downward water movement to be held up or getting cemented, something like that.
And with that, we conclude the DSPS virtual soils training. If you'd like to attend a training like this, but in person, we do offer it multiple times a year across the state. Just be on the lookout on the DSPS website for any postings of that. I'd like to have some special thanks for the DSPS staff members that made this possible. Matt Jansen for presenting, Tim Zaromsky and Jeff Brubaker for helping behind the scenes, and all the other DSPS staff members who made this possible. Thank you for watching. We hope you enjoyed it. If you have any questions or comments, please feel free to reach out to anyone in the department and we'll get back to you as soon as we can.